Hi, welcome back to my class in Spherical Trigonometry. In the last lesson, we took up the mnemonic device in which we divided a circle into 5 parts and we placed the 5 parts of a right spherical triangle that may vary into these 5 parts of a circle. And any of these 5 parts we said can be taken as the middle part, and the parts immediately adjacent to the middle parts are called the adjacent parts, and the other two remaining parts are the opposite parts, the parts opposite the middle part. Today we will now use the mnemonic device for writing the equations using the Napier'S rules. There are two Napier'S rules. The first Napier'S rule states that the sine of a middle part is equal to the product of the tangents of the adjacent parts. And the second Napier'S rule states that the sine of a middle part is equal to the product of the cosines of the opposite parts. We state again the two Napier'S rules. Napier'S rules. Number 1, the sine of a middle part is equal to the product of the tangents of the adjacent parts. Number 2, the sine of a middle part is equal to the product of the cosines of the opposite parts. The Napier'S rules represent the special cases of the spherical law of cosines for a spherical triangle, one of whose sides or one of whose angles is a right angle. Thus, the Napier'S rules applies only for solving spherical triangles that contain a right angle, or the Napier'S rules apply only for right angle spherical triangles. For applying the Napier'S rule, we consider the following example. Example, solve the spherical triangle. As in plane trigonometry, when we say solve the spherical triangle, it means that we have to find all the parts that are not given, or all the unknown. We have to find all the unknown parts of the spherical triangle. Again, solve the spherical triangle whose parts are small a 73 degrees, small b 62 degrees, and capital C equals 90 degrees. Since one of the angles is equal to 90 degrees, or one of the angles is a right angle, specifically angle C is a right angle, the given spherical triangle is a right spherical triangle. One of the surface angles, capital C, is a right angle. And the two sides of the spherical triangle, small a and small b, these are the central angles, the angles that the arcs or the side of the spherical triangle make with the center of the sphere are given. So two central angles are given, and one surface angle is given, capital C, which is a right angle. So to solve this spherical triangle, we have to find the third side, small letter C, because small a and small b are given. Small letter C is the side of the spherical triangle opposite the right angle, capital C equals 90 degrees. And we also have to find the two surface angles of the spherical triangle, capital A, the angle opposite side A, or arc small a, and the surface angle, capital B, the angle opposite the side is small b, or arc is small b. Also, find the area of the spherical triangle if the radius of the sphere is 36 meters. To find the area of the spherical triangle, we have to find first the spherical axis. That is the difference between the sum of the three surface angles and 180 degrees. From the first lesson in spherical triangle, we said that the sum of the three surface angles, capital A plus capital B plus capital C, is greater than 180 degrees but less than 540 degrees. And if we subtract 180 from the sum of the three surface angles, we will get the spherical axis. And only then we can solve for the area of the spherical triangle on the surface of the sphere whose radius is 36 meters. Now we will write the equations using Napier'S rule to solve for the unknown parts of this spherical right triangle. In the given problem, we will find the small letter c, or the side opposite the right angle capital C equals 90 degrees. We will find the surface angle capital A, the angle opposite the given side small a, and the surface angle capital B, the angle opposite side small b. And we place the parts of the spherical triangle in this figure. The right angle is capital C, indicated by this small square. And I indicated this vertex of the spherical triangle by a capital A and the other vertex by capital B. Of course, you can interchange. You can write capital A here and this will be small a. If you write capital B here, this will be small b. For these notations, this is the vertex A and the side opposite is small a. The side opposite the surface angle A is small a equals 73 degrees. And this is the vertex B, the side opposite angle B is small b, or the length of this arc small b is given 62 degrees. And we place the 5 parts of the spherical triangle, small b capital A, small c capital B, and small a into a circle divided into 5 parts. You may start with a small a or a small b. I will start with a small b. I will place small b in this part of the circle. And from small b, we go in counterclockwise direction, but we skip angle C because angle C is already given. We know that angle C is 90 degrees. Hence, after small b, we write angle A. Next to angle A is small small c, the side opposite the right angle C. And next to small c is angle B. And next to angle B is small a. But again, this is not the mnemonic device that we will use to write the equations using the Napier'S rules. The parts that make up the right angle C are small a and small b. And we retain these 2 parts in the mnemonic device. We write A and B in the mnemonic device as is. And the 3 remaining parts that are not connected with the right angle C, we write them as complement of angle A, denoted by A prime. Complement of small c, denoted by C prime. And complement of angle B, denoted by B prime. Now we write the equation using the mnemonic device and Napier'S rules, and from which we can solve for one of these three unknowns, parts of the right spherical triangle. Okay, we start with the small c. To find the small c, we must use complement of c. And according to the first Napier's rule, if c prime is the middle part, the sine of the middle part is equal to the product of the tangents of the adjacent parts. Now you check if you are given angle A and angle B, but these two angles are unknown. Thus, we cannot use the first Napier's rule to write the equation to find small c. Now, the side, if c prime is the middle part, these are the adjacent parts, and small a and small b are the opposite parts. Using the second Napier's rule, the second Napier's rule states that the sine of the middle part is equal to the product of the cosines of the opposite parts. And we are given the opposite parts, small a and small b. Thus, we can solve for angle small c, or the side small c, using the second Napier's rule, that states that the sine of the middle part, we write by second Napier's rule, the second Napier's rule states that the sine of the middle part, c prime, the sine of c prime is the complement of c, is equal to the product of the cosines of the opposite parts, because the opposite parts are small a and small b, and we write cosine of a multiplied by cosine of small b. This is the equation obtained using the second Napier's rule, that states the sine of the middle part, our middle part is c prime, or complement of c. The sine of the middle part is equal to the product of the cosines of the opposite parts. The opposite parts are a and b, and the product of their cosines is given by cosine of small a multiplied by cosine of small b. Now we apply the complement angle theorem, that says the trigonometric function of an angle is equal to the cofunction of the complement of the angle. C prime here is the complement of c, and the complement of the unknown side c is c prime. Therefore, these small c and small c prime are complementary angles. The complement of c prime is c, the complement of c is c prime, and the cofunction of sine is cosine. Thus, by complement angle theorem, the sine of c prime is equal to the cofunction of sine, which is cosine. Cosine of the complement of c prime, and the complement of c prime is small c, is equal to cosine of a multiplied by cosine of b. It is from this equation that we will find the value of small side c. And we now substitute the value of small a, 73 degrees, and the value of small b, 62 degrees. we have cosine of small c is equal to cosine of a, small a is 73 degrees, multiply by cosine of small b is 62 degrees. And this implies that small c is equal to inverse cosine or shape cosine of the cosine of 73 degrees multiplied by cosine of 62 degrees. And we find the side small c using calculator. And the mode of your calculator should be in degree. And we do that, we have we now find the value of the side small c opposite the right angle capital C. In your calculator, you press shift cosine and then open parenthesis, press cosine, press 73, then you press multiply, press cosine, press 62, then press close parenthesis, and then you press equals. And you should get 82.11066.32488 degrees. You should get this answer 82.1106632488 degrees. If we want the answer to 2 decimal places, then the answer should be 82.11. After the decimal point, we want to have 2 decimal places, so the digit to be rounded off is 0. Since 0 is less than 5, we drop 0. And we get 82.11 degrees. But we usually give the answers, the final answer in degree, minutes, and seconds. To write this answer in degree, minutes, and seconds, we take the whole number 82 degrees and from your calculator you subtract 82 and the decimal number you should get is 0.11066.32488 and multiply that by 60 minutes. We multiply by 60 minutes because 1 degree equals 60 minutes. And the answer you will get is 6.6397949.254. Again, to convert the answer in degree, minutes, and seconds, take the whole number 82 degrees and from your calculator you subtract 82, you will get 0.1106632.488 and multiply that decimal number by 60 because 1 degree equals 60 minutes. 0.1106632.4 0.1106632.488 multiplied by 60 is 6.63979 49254. Again, take the whole number. This is 6.6397949,254 minutes. Take the whole number again. 6 minutes. And from your calculator, you subtract 6 minus 6, and you will get 0.63, 0.639 794 9254, and multiply that decimal number by 60 again, because 1 minute equals 60 seconds. And you should get 38.38769 55234. Multiplying this decimal number 0.6397949,254 by 60, you should get 38.38769 55234 seconds. Now you round this up to 2 decimal places. After the decimal point, you count two decimal numbers, 1, 2, and the number to be rounded up is 7. Since 7 is more than 5, we add 1 to the preceding digit 8. And this to 2 decimal places is 38.39 seconds. 38.39 seconds. And this is the side opposite the right angle capital C. Now we have 3 parts of the right spherical triangle. We now have 4 parts of the right spherical triangle. The small a, 73 degrees, small b, 62 degrees, and small c, 62 degrees, 6 minutes, 38.39 seconds, and the right angle, capital C, equals 90 degrees. Only 2 parts now are to be computed, the surface angle, capital A, and the surface angle, capital B. We start with the surface angle, capital A, by the first Napier's rule. If we take A prime, capital A prime as the middle part, small c prime and small b are the adjacent parts. And capital B prime and small a are the opposite parts. And by the first Napier's rule, if A prime is the middle part, the first Napier's rule states that the sine of capital A prime is equal to the product of the tangents of the adjacent parts, small b. Small b is given 62 degrees. And C, and tangent of C prime. And we have C, 62 degrees, 6 minutes, 38.39 seconds. Therefore, we can use the first Napier's rule to write the equation. But if you use the second Napier's rule to find the angle capital A, the second Napier's rule states that the sine of the middle part, sine of capital A prime, is equal to the product of the cosines of the opposite parts. Cosine of small a, cosine small a is given 73 degrees. And cosine of capital B prime. But B, capital B, the surface angle capital B is not given. Thus, we cannot use Napier's second rule to solve for capital angle A. Hence, we will write the equation using the first Napier's rule to find angle A. Write the equation from which we can solve for the angle capital A using the first Napier's rule. The first Napier's rule said that our middle part is capital A prime. The first Napier's rule states that the sine of the middle part is A prime, sine of A prime is equal to the product of the tangents. Product of the tangents of the adjacent parts. If A prime is the middle part, the adjacent parts are B, small b, and a small c prime. The sine of A prime is equal to the product of the tangent of small b, multiplied by tangent of small c prime. But c prime is the complement of c, and capital A prime is the complement of capital A. And we use the complement angle theorem to remove the complement of C and complement of A. By complement angle theorem, the trigonometric function of an angle is equal to the cofunction of the complement of the angle. By complement angle theorem, sine of A prime is equal to cofunction of sine, cosine. Cosine of the complement of the angle A prime. The complement of A prime is angle A, and the complement of A is A prime. Hence, A and A prime are complementary angles. The complement of A prime is angle A, and cosine of A equals tangent of B multiplied by, again we apply the complement angle theorem to tangent of C prime. The tangent of C prime is equal to the cofunction of tangent, which is cotangent. And the complement of small c prime is small c. And the complement of small c is small c prime. That is, c prime and small c are complementary angles. And the complement of small c prime is small c. But in our calculator, we do not have cotangent function in the calculator. We only have the first three basic trigonometric functions in the calculator: sine, cosine, and tangent. So we use a trigonometric identity to rewrite cotangent of angle small c. By the reciprocal identity, cotangent of c is equal to the reciprocal of tangent. We write cosine of capital A equals tangent of small b. Cotangent of small c by trigonometric identity is the reciprocal of angle c, or cotangent c is 1 over tangent small c. And from this equation, we can now solve for A. Angle A equals shift cosine or arc cosine of tangent of B. Tangent B multiplied by 1 is tangent B. Divide by tangent of small c. We substitute the angle small b. It's given angle small b is 62 degrees. Shift cosine of tangent 62 degrees over tangent of small c We have solved for the side small c opposite the right angle capital C. Small c is 82 degrees. Tangent of 82 degrees, 6 minutes, 38.39 seconds. And we compute that using our calculator. Using the calculator, we find the value of angle capital A. In your scientific calculator, you press shift cosine or arc cosine, press open parenthesis, then press tangent, press 62. Your calculator should be in degree mode. Press divide, then press tangent, press 82, and for the degree, you press the key with these symbols. You have a key in your scientific calculator with this symbol for degree, minute, and seconds. After you press tangent, you press 82, then you press this key. This is just one key in the calculator. Press 6, press this key again for minutes. Press 38.39. Then press this key again for seconds. Then you press close parenthesis and then you press the equal sign. And you should get 74.89340.77041. If we want the answer to two decimal places, the answer should be 74.89 degrees. This number is in degrees. To two decimal places, our answer will be 74.89 degrees. But again, we write the final answer in degree, minutes, and seconds. Take the whole number, 74 degrees. 74 degrees. And in your calculator, you subtract 74 from this number. You should get 0.89340.77041. And multiply this decimal number by 60 because this is in degree, we want to convert this in minutes. And 1 degree equals 60 minutes. Hence, we multiply 0.89340.77041 by 60 minutes. You should get 53.60446.22458 minutes. And take the whole number again for 53 minutes. And subtract 53 from this number. You should get 0.6044622.458 minute. And we will convert this minute to seconds. And we take 1 minute equals 60 seconds. Thus, we multiply 0.6044622.458 minute by 60. And you should get 36.26773.47509 seconds. And we round this number to two decimal places now. After the decimal point, you count two decimal number, and the third digit is to be rounded up. Since 7 is more than 5, we add 1 to the preceding digit, 6, and the final answer to two decimal places is 36.27 seconds. 36.27 seconds. And this is the angle A opposite the side small a, which is given, and small a is equal to 73 degrees from the problem we had earlier. And the angle opposite that side small a is equal to 73 degrees, 53 minutes, 36.27 seconds. Now, the only part of the spherical triangle that is unknown is the angle capital B. And we now have the angle small c, we have the angle capital A, and these two sides are given. To find the angle capital B, you may use now either Napier's rule number 1. By Napier's rule number 1, your middle part is capital B prime. By Napier's rule number 1, the sign of the middle part is equal to the product of the tangents of the adjacent parts. Small a is given, we found small c. So you can use Napier's rule number 1. Or you can use Napier's rule number 2 with capital B prime as the middle part. Napier's rule number 2 says that the sine of the middle part is equal to the product of the cosines of the opposite parts. These are the opposite parts, opposite capital B prime. Small b is given and we just found angle A. Hence, to find capital angle B, you may use Napier's rule number 1 or Napier's rule number 2. To find angle capital B by the second Napier's rule. In the mnemonic device, we take the capital B prime as the middle part. And by the second Napier's rule, the sign of the middle part, the sign of capital B prime, sign of B prime is equal to the product of the cosines of the opposite parts. With B prime as the middle part, the opposite parts are capital A prime and small b. And by the second Napier's rule, the sign of the middle part, capital B prime, is equal to the product of the cosine of capital A prime, cosine of capital A prime, and cosine of small b, cosine of small b. Again, by second Napier's rule, the sign of the middle part, capital B prime, is equal to the product of the cosine of the opposite parts, cosine of A prime and cosine of B. It is from this equation that we will solve for angle capital B, but we have to remove complement of A and complement of B using the complement angle theorem. The complement angle theorem states that the trigonometric function of an angle is equal to the cofunction of the complement of the angle. Thus, applying the complement angle theorem to sine of capital B prime, the sine of capital B prime is equal to the cofunction of sine, which is cosine, cosine of the complement of B prime. The complement of B prime is angle capital B. Angle capital B and angle capital B prime are complementary angles. Thus, the complement of capital B prime is capital B. And again, by complement angle theorem, the cosine of capital A prime is equal to the cofunction of cosine, which is sine of the complement of the angle A prime. The complement of the angle A, capital A prime, is angle capital A. These angle capital A and capital A prime are complementary angles. The complement of capital A is capital A prime and the complement of capital A prime is capital A. Now we substitute the values of angle capital A and the side is small b. Earlier, we found angle capital A, 74 degrees, 53 minutes, 36.27 seconds. Multiplied by cosine of small b. Small b is given 62 degrees. Hence, from this equation, angle B is equal to shape cosine or arc cosine of sine of 74 degrees, 53 minutes, 36.27 seconds multiplied by cosine of 62 degrees. And use your scientific calculator. to find the value of this. You press cosine. Your calculator should be in degree mode. Press shift cosine or arc cosine in your scientific calculator. Press open parenthesis. Press sine. Press 74. And you press degree. Press 53. You press again the key in your calculator with this symbol. For minutes, press 36.27. Press this key in your calculator for the seconds. Then press multiply, press cosine, press 62, and press press close parenthesis, and then press the equal sign. And you should get 63.0477442336 degrees. The number that you should get is in degrees, 63.0477442336 degrees. If we want the answer to two decimal places, after the decimal point, you count two decimal numbers, 1, 2, and the third decimal number, 7, is to be rounded up. Since 7 is more than 5, we add 1 to the preceding digit 4. Hence, the angle capital V to two decimal places should be 63.05 degrees. But we give the answer to, we give the angle in degree, minutes, and seconds. For the degree part, you take the whole number, that's 63 degrees. And subtract 63 from 63.04. 63.04 77 44 2336 minus 63. You should get 0.0477442336. And that's in degree. And we multiply this decimal number by 60 because 1 degree is 60 minutes. Multiply 0.0477442336 by 60, and you should get 2.86. 2.8646544016. And this is in minutes, 2.864654016 minutes. Take the whole number again, 2 minutes. And subtract 2 from this number. You should get 0.8646544016. After subtracting 2 from 2.864654016, you should get 0.8646544016. And that's in minute. To convert that in seconds, multiply this decimal number by 60. And you should get 51.879. 51.879 24096. This is in seconds. And we round this decimal number to two decimal places. After the decimal point, you count two decimal numbers. And the third decimal number, 9, is to be rounded up. Since 9 is more than 5, plus 1 to the preceding digit. And this decimal number to two decimal places is 51.88. seconds. 51.88 seconds. 51.88 seconds. So we have solved for all the unknown parts of the right spherical triangle. Now we can calculate the area of the spherical triangle using the following formula. A equals pi r squared multiplied by E divided by 180 degrees. This is the formula to calculate the area of the spherical triangle. Pi multiplied by the square of r, where r is the radius of the sphere, multiplied by the spherical axis, which is obtained by subtracting 180 from the sum of the three surface angles of the spherical triangle, and dividing the product by 180 degrees. We calculate the spherical axis E. The spherical axis E equals the sum of the three surface angles, capital A, capital B, capital C, minus 180 degrees. Or the spherical axis E equals angle A is 74 degrees, 53 minutes. 74 degrees, 53 minutes, 36.27 seconds. Plus angle B, 63 degrees, 2 minutes, 51.88 seconds. Plus the right angle C, 90 degrees. Minus 180 degrees. And we give the answer in degree because the product in the numerator is to be divided by 180 degrees. We write the spherical axis in degrees so that degree will cancel out from the numerator and denominator. Your scientific calculator, we find the spherical axis, the sum of 74 degrees, 53 minutes, 36.27 seconds, plus 63 degrees, 2 minutes, 51.88 seconds, plus the right angle 90 degrees, is 227.9411527778 degrees. And from this sum, we subtract 180 degrees, which gives us 47.9411527778 degrees. This is the spherical axis that we substitute in the formula for calculating the area of a spherical triangle. We will not round it off yet. We will round up the final answer. We will do the rounding off when we get the final answer. We substitute the spherical axis into this formula, and the given radius of the sphere equals to 36 meters. Area of a spherical triangle equals pi multiplied by square of the radius. The radius is 36 meters, 36 square, multiplied by the spherical axis, 47.9411527778 degrees, and the product is divided by 180 degrees. The degree in the numerator and degree in the denominator will cancel out, and the unit will be square meter or meter square. And the product of this divided by 180 gives 1084.40332.82783 square meter. We round this up to 2 decimal places. After the decimal point, we count 2 decimal numbers, and the third decimal number is to be rounded up. Since 3 is less than 5, we simply drop 3. and we do not add 1 to the preceding digit. So the area of the spherical triangle, the area of the right spherical triangle is 1084.40 square meter. For practice, please try the following exercise. Solve the spherical triangle with capital C equals 90 degrees. Thus, the given spherical triangle is a right spherical triangle with the right angle at vertex C. That is, angle C equals 90 degrees. Small a is 50 degrees and small c is 80 degrees. Small a and small c are the two sides of the right spherical triangle. Small c is the measure of the side opposite the right angle capital C, and small a equals 50 degrees is the side opposite the angle capital A of the spherical right triangle. Also, find the area of spherical triangle if the radius of a sphere is 27 meters. The first step that you will do is you draw the mnemonic device, identify the unknown. To solve the spherical triangle means to find all the unknown parts, the parts that are not given. And in this problem, you will use the Napier'S rule and the mnemonic device. For you to check your answers, whether they are not correct or not, we have the following correct answers. The angle B is 77 degrees 52 minutes. This answer is correct up to the minute part. The angle A is 51 degrees 04 minutes. And the side small b is 74 degrees 20 minutes. But you also have to calculate the area of the spherical triangle. The radius of the sphere is 27 meters. And the formula for area of the spherical triangle is pi multiplied by the square of the radius multiplied by the spherical axis divided by 180 degrees. You have to find first the angles A and B and add it to the right angle, and from the sum you subtract 180 degrees to get the spherical axis denoted by capital E. If you have a question about the lesson today, please ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan. Thank you.